see whether it works. And
Sorry.
great. Good. Okay, agreed to that. And so I want to address this question: what makes an experiment beautiful? Suggest some answer to this question, and also at the end, I will leave you with some further questions that are interesting and I'm working on at the moment, and that I hope we can all collectively consider. I think they're really important. So the first thing I'll start with is just stating the obvious, that in science we do really interesting stuff. We're dealing with beautiful things all the time. And it's really fascinating to understand what role aesthetic considerations play in scientific practice, but also how beauty enters in things that we do, right? How we select what's interesting to study, how we select what model to construct, what theory to construct. And here's some pictures of just a few things that are just clearly very beautiful in nature. Some of them are naturally there, some of them appear in our labs under certain conditions, but we find all sorts of beautiful things in the world, from fossils and perfect hexagonal beehives to these beautiful processes of crystallization, the protein structures, molecules. These pictures are of a jellyfish that are incredible. There's all sorts of beautiful things in nature. And we find the phenomena that we study very aesthetically pleasing. And whether that affects whether we even want to engage with the subject is an interesting question. But beyond that observation, that of course, nature is beautiful and we study it for that reason, there's also the even more interesting, in my opinion, side that a lot of the things that we create in science are considered aesthetically valuable, pleasing, and beautiful. And this can be in the form of models, theories, experiments, and even the process that we use, how we construct a molecule, how we construct an experiment can be very much conceived as an artistic kind of act. A lot of scientists compare themselves to artists, compare the process by which they create, compare that process to the artistic process of producing an artwork. There's clear similarities between the scientist and the artist, and they're worthy of exploration by us, the philosophers of science, to understand better the relationship between beauty and aesthetic considerations in general, how they affect us in what we do, how they affect the pursuit of knowledge, and of course to understand also the relationship between aesthetics and philosophy of science. So I want to start by just drawing a distinction between three things. I already alluded to them a little bit. The fact that we can make aesthetic judgments and specifically claim beauty in a number of ways and in a number of different contexts. One of them concerns the objects that we study. Quite obviously, we saw some beautiful phenomena and beautiful things like a protein structure, or what we see under the microscope when we look at a cell. The objects that we study, whether they're naturally occurring or produced in the lab, they can be beautiful. They can exhibit properties that we find aesthetically pleasing and valuable. We saw fossils, solar eclipses, think about the prisms and the rainbows. All sorts of phenomena we can find beautiful. That's very different to the other aspect in which we employ aesthetic considerations, and that's the products that we create, the products of our engagement with a subject, right? So we can recall how many times physicists have said general relativity is a beautiful theory, or the DNA structure, a molecule structure of the double helix structure of DNA is a beautiful model, or the C60 molecule is a beautiful molecule. We even thought experiments, of course, have been also praised by those terms as well, and experiments performed in labs. All of those kind of products, I want to call them, of our engagement receive aesthetic praise and are often labeled as beautiful. And then on the other hand, is also the process and the very act by which we produce these things that we find beautiful, whatever they are, from models and simulations to experiments and theories, we can find that process also to have similarity to an artistic production, to engage our aesthetic sensibility, our creative thinking, our imaginative thinking, and to kind of infuse the product that we're creating with that aesthetic sensibility. And so here we can think about, the very process of making a fossil. We don't just find the fossil in nature, we construct it. That infuses our aesthetic, is infused by our aesthetic sensibility, as it has been wonderfully presented by Caitlin Wiley in her just published book, Preparing Dinosaurs. She illustrates that really, really nicely, how the preparators use their aesthetic judgment when they are working on a fossil. The very construction of an experiment also is infused with our aesthetic considerations and aesthetic sensibility. And often we see that scientists themselves, when reflect on the process of their engagement, they will compare this work to artistic production. They will we'll see that there's this lovely quote from Einstein comparing Michelson to the artist in science, because he had this aesthetic sensibility that made everything he worked on really beautiful. So these are three different kind of aspects in which we can find aesthetic judgments. I think it's important we keep kind of the distinction in our minds when we start thinking about experiments later on. But now I want to just say a few things about where we are at in the literature. And start, of course, by saying that in philosophy of science, we haven't always thought that it's important to look into these aesthetic considerations in science. And the reason why is because we used to, and of course, many people still accept that there's this very clear delineation of how we discover and the considerations that we employ when we discover. But there's also the very other different picture when we get to form our beliefs about the world. There we want to evaluate the evidence in a very objective and not the way in which we infuse the kind of reasoning with personal subjective values. And aesthetic values, because they were considered so subjective and ephemeral, changing, we didn't want to associate the production of knowledge with those. We wanted to think accept the kind of context of justification is separated from this context of discovery, where people can be affected with whatever values they want. So that kind of delineation, of course, affected how much philosophers of science were really paying attention to these factors. But in the last few years, we've seen a very welcomed engagement between aesthetics and philosophy of science. And that started kind of with the book here, the edited collection, Beyond Mimesis and Convention, which kind of dealt with the notion of representation and thought, for us to understand how scientific theories represent the world, we have to look into the notion of representation, which was kind of further developed in the second edited volume here, thinking about science and reflecting on art. And last year, super exciting work came out dealing with the scientific imagination. And this work is really paying close attention into how we use creativity and imagination in many different ways in science. And the edited collection that I worked on with Stephen French, again, started quite a few new kind of directions of exploration, thinking about the nature of aesthetic responses in science, to how the aesthetic relates to the epistemic, how they tied in through the understanding, reflecting on cognitive agents, and how the aesthetic dimension reflects cognition. And there was a lot of other interesting works there, the nature of thought experiments and their aesthetic appreciation. So there's a lot of interest in philosophy of science. The reason why I'm mentioning this, because I want to show you this kind of momentum at the moment going on in philosophy of science, with a lot more attention being paid to the intersection between philosophy of science and aesthetics. And further to those edited collections, there's a few papers that I wanted to mention as well that are really interesting. So thinking about aesthetics and paleontology, Caitlin Wiley has done amazing work here, David Turner and Adrian Curry as well. There's also work looking into how molecular biology, studies in molecular biology are affected by aesthetic considerations. Furthermore, some work comparing thought experiments to literary fictions and trying to understand them through this aesthetic dimension. Also work depicting how studies in anatomy are traditionally related to artistic practice. I mean, even today, depicting the human body very often involves artists, and artists very often have to look into the science to get, there's always been this kind of relationship between anatomy and art. And the paper that deserves a lot of credit for starting this question is, of course, Glenn Parsons and Alexander Ruger, who wrote a paper in 2000 about the fact that experiments could be appreciated aesthetically. And they were talking specifically about experiments in early scientific practice going into 20th century. So there was acknowledgement in the literature that these experiments can provoke aesthetic responses, but hardly anything after that. So today, hopefully we're going to move forward a little bit. But before we do that, I want to talk a little bit about the role of beauty in science as the kind of current framework that exists and how we think about what beauty does for us in science, how seriously we should take it. Then I'm going to look into a very obvious way in which we can give an answer to this question that I'm asking, what is a beautiful experiment? I'm going to dismiss these answers and then develop another way of thinking about the aesthetic value of an experiment, and specifically what makes it beautiful, by arguing that it's a very special interplay between design and significance. And then I'm going to consider some implications and develop a more pluralistic outlook on the nature of aesthetic responses in science and the aims that we have when we make an experiment. So, what is the role of beauty in science? As I mentioned earlier, for a very long time, we had this kind of idea in philosophy of science that, well, it's kind of irrelevant to epistemic goals. It's kind of interesting to find how someone thought and came out with an idea, the personal values that led them to it. But when we get to evaluate how good that idea is, we don't really want to be meddling with the aesthetic. There has to be a clear delineation. For some, for some is motivational. It's ultimately what drives us to do science, what kind of makes us motivated to explore nature because we find it beautiful. So it's what kind of drives scientific research. For some, it is pragmatic. It can be useful to use beauty, to utilize beauty considerations, aesthetic considerations more broadly in science. But there's also the epistemic dimension where we think there is something to it. Beautiful theories, for instance, are to be trusted. So let's unpack a little bit, just see a few examples of these kind of ways to see beauty in science in particular. Hans Reichenbach, of course, is the philosopher who introduced this distinction between context of discovery and justification, and in a sense demoted the aesthetic considerations to discovery rather than justification, arguing that if we want to kind of think about science as giving us objective truths about the world, we can't allow these kind of aesthetic factors in these evaluations, simply because they're subjective and ephemeral, they change, so we can't shape scientific knowledge on such shaky grounds. For some, beauty is a motivation. And here, Henri Poincaré, who you will hear and noted a few times in the talk, as he is my favorite philosopher, the scientist, he says, does not study nature simply because it's useful to do so. He studies because we want to find pleasure in it. And what kind of pleasure? Of course, he's talking about the very intimate pleasure that comes in from understanding something like a phenomenon and finding beauty in there. And that's what motivates the scientist. And the Nobel laureate, Sir Chandrasekhar, who used to be also a fellow in Trinity College here in Cambridge, he would argue that artists and scientists have the same aims. They want to discover beauty. He wrote an entire book about beauty and truth to convince contemporary scientists at the time of how important it was to trust your aesthetic sensibility, how important it was to kind of develop that aesthetic sensibility. So for him, it is a motivation. we'll see that it's also beyond that. But there's also the pragmatic factor. And here's Pierre Duhem, who kind of reflecting on how we make choices when we are kind of deprived of evidence, maybe in a situation where our evidence is not pointing just into one theory. He also noted that, of course, we're impacted by these kind of factors, such as elegance and simplicity, but let's not forget they're subjective and contingent, variable, and ultimately they'll never have the same weight as pointing at an evidence that can be accommodated within the theory. So even though it can be useful to use these when we don't have evidence, ultimately we want to get to the evidence to properly ground our beliefs. And Basra and Prasen similarly, of course, reflects that these kind of considerations are just a function of our interests and pleasures. Whether they can help us make choices, we need to remember that they cannot be rational guides to our epistemic attitudes. So beauty cannot drive our belief to trust a theory. Evidence will do so. But then there's other scientists who have, and philosophers, of course, who have expressed a much stronger view. Beauty is a reason to trust a theory. And there was so much discussion, as I'm sure you know very, very well, better than me, so much discussion about general relativity pre and post 1919 about why you should trust this theory. And so many of these discussions were based on aesthetic considerations, reflections on how beautiful the theory was, mathematically beautiful, so unifying and so elegant, and so many kind of correspondences between Einstein and other contemporary scientists at the time, like Paul Dirac and Heisenberg here, particular with their claims that this is what made them convinced in the theory. It wasn't the evidence. The evidence was great, but it was also the beauty of the theory. You couldn't help but think it's true since it was so beautiful. And they're definitely not alone when expressing these kind of tendencies. Here's another more recent particle physicist, Michaelmas, who claimed, in fundamental physics, beauty can help us kind of guide our belief in the theory because it's much more likely to be true than an inelegant one. If you have an elegant theory, that's something. And again, Chandrasekhar here arguing that we have evidence that the theory developed by a scientist with an exceptionally well-developed aesthetic sensibility can turn out to be true even when we don't have evidence for it. And that's why I was saying a little bit earlier, the entire book is there to convince us that we have good evidence to trust beauty and good reasons to try and kind of develop those aesthetic sensibilities in a scientist. They are very, very important. How can we possibly justify such a link? Well, I think at the moment, when we look at philosophy of science, there are two different schools of thought, and they're not quite integrated with each other, but they kind of employ the same argument at the end of the day, and that's an inductive projection argument, track record argument, to call it slightly differently. One comes from the scientific realism literature, where some philosophers of science have kind of correlated these traditionally understood as theoretical virtues that very much are reflecting the kind of judgments that scientists make when they call a theory beautiful: simplicity, elegance, and unification, and symmetry. And in this literature, the argument is, well, we just simply base our confidence in light of just the track record of some virtues. If we keep educating ourselves in physics and keep seeing these unifying theories, how could we possibly not trust unification? It's just a projection of the past success of the virtues, such as the unifying power of theories. That would be the virtue. And James McAllister, on the other hand, is a philosopher of science who is not interested in kind of justifying realism, but he thinks it's justified to trust aesthetic criteria. It's rational to trust them because, again, we have good reasons to make these aesthetic inductions in science and project expectation that if a theory comes along that exhibits the aesthetic values of previous theories, well, it's more likely to be on the right track. And I've argued that I find these arguments rather inconclusive. And one good kind of recent account that illustrates how inconclusive is coming from Sabine Hossenfelder, who argues that we should be alarmed when we use beauty in science, because even though it can be very rewarding to find it, and it can be very motivational to get us involved in a particular research field, it can also be a bias, because it can be ultimately leading us into research projects that are not very productive, simply because we're holding on to certain ideals that we consider very important and related to not only aesthetic pleasure, but also epistemic success. And her argument, which I find really, really good in this respect, is the fact that we can make these inductive arguments in both directions. We can find very pleasing theories that didn't end up being successful, so we could infer, lack of success from beauty, but we can also find theories that don't necessarily seem to score very high on the aesthetic value that we actually really value for epistemic reasons. So this is all just to say that at the moment, this, I think, approach to justifying epistemic significance is rather inconclusive with these kind of aesthetic induction arguments types. But there's also a different way in which philosophers are thinking about beauty, and that's to kind of link it to just cognitive agency and how people think and what kind of expectations people have and the kind of explanations they want to construe and accept. And that's coming a little bit after Kate Algan's book and her work on the employment of religious falsehoods, but also on just redefining the aims of science and kind of shifting it not towards truth, but towards understanding, which can accommodate for sometimes utilizing falsehoods in our theories, in our practice. And this kind of debate is still trying to preserve some value for beauty, but definitely not making the stronger claim that beauty is related or indicates truth. So that's one part of this debate, for which I'm not going to talk too much about, but there's another part of this debate which is simply interested in how much are these judgments contributing, or can we say that these judgments can really guide us in anything if they are changing constantly, if they are evolving, if in science we can't find the same meaning of beauty between two different periods, how could we possibly think that then this can be informing our attitudes towards a theory, for instance? Here, some people simply take it that beauty, for instance, is a dynamic notion, it changes what it means, and others think, well, actually, it's pretty stable across different periods of time. There isn't much of a deviation, so we could potentially find commonalities. There isn't these big kind of revolutions in our understanding of beauty. So this is just to kind of indicate what's out there in the literature and give us a little bit of an indication that there is a question about, what are these judgments really? Are they stable? Do they change? The nature of these judgments that we make, and also what is their function. Now, I'm really interested to see the kind of answers we will give to understanding the epistemic and the aesthetic significance of experiments, whether they will give us interesting questions to the previous questions. I think they might lead us to think slightly differently about these two questions about nature and function of aesthetic judgments. But with that, let's start to think a little bit about the experiments, right? As I mentioned before, in this literature, the experiments are quite absent, and it seems very strange. So first thing first, experiments deal with a lot of beautiful things, right? Experiments can be beautiful for very obvious reasons. They're just presenting to us beautiful images or beautiful phenomena unfolding under the microscope or whatever instrument we are using. We can just see beautiful things. And that's one very obvious answer what makes an experiment beautiful. Well, just seeing something that's really lovely. Here's just some pictures of crystals. Obviously this is very, very impressive, very beautiful. And the fact that we can see fascinating, beautiful things in an experimental setting kind of motivated a lot of early days experimental practice to be quite public and to present in a very artistic manner what was going to happen in a particular experimental setting with a particular instrument. Here is the famous picture by Joseph Wright-Adobe, and presenting the experiment on a bird with the air pump. And you can learn so much about the scientific kind of the experimental practice at the time by just looking at it, because it shows you, first of all, that there's an audience, there is a performer. The experimenter is a performer. He's trying to fascinate everybody to see what will happen under this, very fascinating, new, previously uncharted condition, creating a vacuum. And you can also see that there's a lot of different people that are feeling a lot of different things. The aesthetic nature of the response that they're having is very diverse, from complete awe and fascination to quite terror and horror and wanting to just move away, not to see what's going to happen to this poor bird in a few minutes. That kind of captures a really important aspect about experimental practice. Experimental practice can be, very much a performative one, and the experiment can be seen as a spectacle, something really interesting that's happening, something that can fascinate us and provoke in us aesthetic responses. And the fact that this happens was very much acknowledged by natural philosophers, for instance, at the time, at the early days of the Royal Society. They weren't just performing an experiment. They also wanted to give that spectacle to an audience, and they were very aware that that was one of the goals when they were performing the experiments. Here's Joseph Priestley, for instance, when he was reflecting in his notes on electric experiments, how the experiments offered this delightful spectacle, that they were beautiful and they provoked feelings of pleasure and awe and amusement. And we see that a lot of the time the experimenters are almost compared to like a performance, like a theater performance. Now that's, at least at this particular period of experimental practice, there was a very much underlying assumption that nature is beautiful, well-ordered, symmetric, elegant, and the goal is to display that, to unveil it to the public, right? To the an educated and trained eye. They wanted to bring it about. And one of the famous illustrations from Robert Hooke is kind of exemplifying this, the famous flea, the fact that he didn't think it was enough to just, reproduce the specimen. He had to enhance its properties. Why? Well, because we need to ensure that nature will fascinate, nature will evoke these aesthetic responses. We will be motivated to further engage with it because we find it beautiful, we find it fascinating and really pleasing. And this is kind of one type of answer you could give, that, well, of course, an experiment is beautiful when you see something really beautiful, whatever setting we're talking about. Maybe experiments today are not public spectacle anymore. Some of them are. Here's a picture of the pitch drop experiment. I used to pass by it every day when I was at the University of Queensland, and I used to think about the fact that this is a public spectacle experiment that very much looks like the kind of experiments we used to perform a lot more during the early days of the Royal Society. But you can also think, yeah, there's something fascinating even in the chemical retorts and the prisms or the instruments that we use in a lab. A lot of instruments from previous experimental traditions are now hosted in museums and in art galleries because they can have also aesthetic features. So it's not only that the phenomena we've studied will be beautiful, the setup can be also very pleasing, right? So here's all this lovely chemical methods that they used in a chemical lab to create kind of perform experiments. So these are visual features that have aesthetic value, of course. We can also kind of think about, the performance aspect, which very much is not part of modern day experiments so much. But these are four obvious senses in which an experiment can be found beautiful. Well, it can be like an artistic performance. It can generate aesthetic experiences in us by just looking at the performance. We can see very pleasing features in how the experiment is implemented. right? It can be the instruments that we find really pleasing. It can be, the way the experiment is performed. It can be simply because it's exposing, unveiling a beautiful phenomenon, and that's what's beautiful about the experiment. And in all of these kind of answers we could give, the immediate answers, we can kind of appreciate that we are dealing with a sense in which the aesthetic value is immediately given to us, right? It's just a visually pleasing thing. And a lot of chemists, even today, share this idea that, we engage with the subject because it's so visually pleasing. I want to say that even though these are, of course, features of experiments, and of course, worthwhile appraising, and that's not really the kind of the important feature of a beautiful experiment. What I want to say is a beautiful experiment is beautiful mostly and most importantly because of the thing that it teaches us, how it teaches us, and the way in which the experimenters created the setup. So it's going to be an interplay between design and significance of what the experiment showed us. So we care about experiments that teach us something really important. We care about how they did that by having a very beautiful, elegant design, economical, app design for purpose. And we care to also kind of appraise the scientists for constructing it in such a way. So there's also a kind of a value with respect to the ingenuity and innovation of the experimenters themselves. So I'm going to try to illustrate why this makes sense to think it like that. So it's not committing me to every experiment will be visually beautiful at all. I'm not going to be looking into any visual features really. It's about understanding how the experiment achieved its goal and achieved the significance that it had through a very kind of interesting, economical, elegant, original design. To start with, I want to just say a couple of things about the microsymbol experiment and how that kind of a few things that have been said about it motivate us to think that, yeah, it is really beautiful. Experiments are having this elegant design and are significant, and they really are kind of a product of very creative thinking. Albert Einstein, as I mentioned in the beginning, when he was thinking about this experiment, has this really lovely quote that he thought that Michelson was the artist in science, and he took great joy in the creation of a beautiful experiment and the elegance of the methods that he employed to create it. And when we kind of reflect on the experiment and how it was designed and how it was set up, there was so much attention to constructing a really meticulous setup, ensuring that there is, elimination of any possible interference, and just really construction of a really precise machine that was able to detect these small effects. That's really what's really kind of praiseworthy about it. And Jared Holton reflects that nobody before Michelson was able to imagine and construct an apparatus to measure the second order effect of the presumed ether drift, that the interferometer in itself was a lovely thing. I'm not going to talk too much about the microsymbol experiment today, but I want to focus on another experiment simply because that experiment has been subject of so much discussion and so much aesthetic praise by scientists themselves that I think better illustrates what I want to talk about today. The experiment comes from biology. It's the Messerschmitt experiment, and according to most biologists, this is the most beautiful experiment in science, or at least in biology. Sometimes there are polls about what is the most beautiful experiment that you can think of among scientists, and this one is always a favorite. And certainly in the more popularized books and the books amongst historians, it's very much kind of systematically praised as the most beautiful experiment in science. Why is this the case? Well, to understand its aesthetic import and aesthetic value, it's important to understand the context within which this experiment was designed. right? So the experiment is carried out just a few years after one of the most exciting discoveries of the 20th century. In 1953, we have the discovery of the structure of DNA. We now understand that it's a double helix structure, and the most immediate question that the scientific community had to address now is how does this how DNA replicates? And there were three immediate proponents in the community for different alternative hypotheses as to how DNA replicates. One of them arguing that DNA replicates in a conservative way, meaning that basically we preserve one of the original strands of the DNA molecule and we have a newly synthesized one. The semi-conservative arguing that the DNA really just splits into each one strand, acts as a template in which the new molecules are synthesized. And then there's the dispersive replication where the DNA kind of breaks in intervals, kind of acting as a template to synthesize the daughter DNA. And so three proponents and the method now basically set out to address this question, to answer this question, very specific question, how do we understand replication? And what they did very simply, very briefly, is to feed bacteria very heavy nitrogen and see how the DNA starts multiplying, because we knew at what intervals the bacteria are multiplying, seeing how the genetic material changes in the next generations, and then basically feeding them light nitrogen and 14, and seeing what kind of bands they obtain. They were able to extract and see the weight of the genetic material using centrifugation, which is a really original thing that they did. And by obtaining the bands, by just seeing what happens to the genetic material, how heavy it was in the next generations, they were able to basically immediately eliminate dispersive and conservative models, confirming that DNA replicates in a semi-conservative way. Why is this a beautiful experiment? Well, the design was so apt for purpose and so elegant. The thinking behind it was so original. The fact that they realized that they could use weight to kind of affect the weight of DNA, not alter anything else about it, and were able to extract information as to how it changes in the next generations. That was ingenious about the design of the experiment. And clearly the experiment was very significant in what it taught us and how it did so. So a few kind of scientists and historians of science, historians of biology, have reflected on the beauty of this experiment. And here's Ernst-Peter Fischer, that in his book, Beauty and the Beast, the aesthetic moment in science, argues that one condition of this experiment consisted in making the genetic material physically heavy without changing it, right? Without changing anything about its chemical properties. There is something beautiful about that idea alone. So the fact that they realized we could use it, so one of the difficult things at the time was just to understand how do we label this genetic material and understand how it preserves and how it changes in the next generations. The fact that they could use the weight and the process of centrifugation was very original and apt for purpose. Frederick Holmes, in his reflection on this experiment, a whole book written about the significance of this work, argues that the beauty of this experiment is invariably connected with its simplicity. When we reduce it to its essential features, it is readily understood even by beginning students of the life sciences. Teachers look at this experiment with fondness for the ease with which the message can be conveyed. Simplicity here is understood as, the steps are straightforward. The steps are easy. We can kind of strip the way in which the experiment is kind of constructed and follow the reasoning that they implemented. So simplicity, elegance here are the features. But another thing that was really important about this experiment was the way in which it delivered the results. And James Watson himself, one of the discoverers of the DNA structure, argued that the results gave a simple answer to a question. It kind of ticked the box against the semi-conservative replication and eliminated the other contenders in a conclusive way. Ernst Peter Fischer again has argued that these experiments speak for themselves and made further commentary superfluous. What that meant is that the way the experiment was set up, it kind of made it rather conclusive. You didn't have to repeat it again and again. It was quite strong in the way that it spoke for semi-conservative replication. And Frederick Holmes argued that there was something immediate about the results. They were just basically a single historical event that these two scientists observed, and they didn't have to replicate it. And of course, Holmes has reflected that this is quite uncharacteristic of most experiments. Most experiments don't have that immediateness, but this is what makes this particular experiment so special, so beautiful. This kind of immediate way with which it taught us the lesson that it was supposed to, right? And so it is quite easy to conclude that a beautiful experiment is a crucial experiment in science, which gives us an answer to a question, right? It conclusively settles a debate. This is what we understand by a crucial experiment in science. And as James mentioned recently, I've been thinking about the nature of crucial experiments and the holistic problem and whether there are such things as crucial experiments. And it's really interesting that when philosophers of science get to worry about this problem, we get to ask this question, can we even have a crucial experiment? Is a crucial experiment ever possible? We can also think, well, most of the time we have pretty good reasons, or at least in some circumstances, we have good reasons to trust an experimental result and its conclusiveness. If ever there is an example of this is the experiment people will bring into attention. So even when people are perfectly aware of the problematic nature of this concept of a crucial experiment, this experiment seems to really kind of pass worries. Not by everyone, but most people will kind of think, if ever there was an example of a good crucial experiment, this was the one. So far, I've argued that what made the experiment beautiful really was about the design, simplicity, and economy, the elegance, minimal steps, and the artness, how well it was suited for its purpose. And there was beauty, not just because the design was beautiful and good, but also because the results were very significant. It taught us something important that we asked the experiment to teach us. And there was this immediateness, conclusiveness about the result. Now I want to explore some implications from this answer and ultimately defend a little bit of a broader notion, both of experimental goals, but also of experimental, of aesthetic responses we might be thinking about. So one of the things about this experiment is that we take it, the Messer's and Stowe experiment, we take it to be a crucial experiment, and there was something conclusive and immediate about it. But as I already mentioned, not every experiment has immediateness to them, and we wouldn't want to limit ultimately our conception of a beautiful experiment to only those experiments that immediately present something to us. Some experiments will not be so conclusive or immediate. Some experiments can carry over a long time, or we need more of them in different types of experiments as well to be able to say, we've kind of concluded something. And sometimes just extracting and analyzing data can be quite laborious until we decide, well, do we have an event in the collider? And what is that event indicating, right? It's not immediate. That's not problematic at all, I think. Obviously, the aesthetic experience doesn't have to be immediate. I mean, the same thing holds for appreciating artworks. Some artworks promote very immediate responses in us, and some take their time. So I don't think there's anything problematic, but I think if we followed in the lead of the Messer's and Stowe experiment and understood it as something that's immediately presented, we might unnecessarily limit how we understand the nature of beauty in scientific experimentation. So I wouldn't want to really hold on to the request that that's an immediately available kind of lesson to us. The experience can be more timely. And also, I wouldn't want to commit to an experiment being beautiful only when it does something quite significant in the sense of simply detects a particle we predicted, or just tells us, yes, this is the hypothesis that is correct among some alternatives. I think we need to think a little bit more broadly about what significance means of results in an experiment, and recognize also that experiments have plurality of aims. There's not only just one goal. Often experiments have many different goals in their agenda, and the significance of what they obtain can be varied as well. So just to illustrate this with an obvious example, well, the experiments we ran at the LHC in CERN, we don't just have one aim. They didn't just aim to discover the Higgs boson as they did. They have a lot of other aims, of course, to discover other particles that are predicted by the standard model. That hasn't happened yet and doesn't look likely. They also want to just explore, right? They want to explore energy ranges that have not been accessible to us before. And hopefully the big kind of goal behind all this is that we can get an indication of how to transform the physics and develop it further and maybe refine it and revise it. So there are these grand goals, and I don't want to undermine the detection of the particle as not a grand goal, but there's, I guess, more generic questions at the back that we hope for, and more specific goals, such as the detection of specific particles. So what does this tell us? Well, sometimes I want to say experiments can be considered significant and for that reason beautiful, because they actually give surprising, unexpected, and sometimes even disturbing, disruptive results that we don't expect and we don't immediately know how to accommodate for. And that is just to say that a beautiful experiment can give aesthetic response which is not necessarily pleasing. You can move into thinking about the aesthetic response in being a bit more disturbing, perhaps. Maybe even think about sublime responses to results. And that should be accommodated within our understanding of what makes an experiment beautiful and aesthetically valuable. And I think we should see disruption, at least in some cases, as a response that has very important significance. So a couple of examples, right? We mentioned earlier the microsymbol experiment. Is that a beautiful experiment? Clearly, we want to say so because it's really beautifully designed and it has incredible significance. But did it accomplish its goal? It's a question mark how we understand the null results, right? But they are significant and they push forward our understanding of the subject matter. In that sense, they are significant. Did they feel immediately beautiful the way the meshes and Stav experiment felt? Well, certainly not, because we had to do a lot of work to understand how to accommodate for them. And similar with the LHC experiments, right? Not detecting supersymmetric particles. What is going to happen? These are going to ultimately be disruptive, understood as disruptive results, disruptive aesthetic experiences as well, that are more fascinating and more awe-provoking and mysterious, and that can lead us to think that they're not only there because we might have to revise our theoretical commitments or maybe our theory that we have, but in the second case with the standard model, we actually even questioning the basic fundamental principles that have guided the construction of physical theories in the last century, right? Those kind of values that Sabine Hossenfelder claims are now accounting as biases, right? Symmetry principles and elegance and naturalness. So I want to say that we would like to have a framework that accommodates for that as well. The null results sometimes we get can be seen as equally or even more important, and how the result got there and how the experiment got to those results can be seen as ultimately beautiful and aesthetically pleasing and valuable and aesthetically disruptive as well. And this is not so disanalogous to artworks as well. Not all artworks can be found pleasing and straightforward in their interpretation. Sometimes artworks can be very disturbing and disruptive, and the aesthetic value lies in the fact that they get us to question things that we take for granted, right? one of the things they question sometimes is what an artwork is and what the aesthetic experience is supposed to be. So to summarize, as I think I'm approaching to the end of my time, I wanted to offer a framework which accommodates for how we get to appreciate aesthetically the scientific experiments, why we claim that the experiments are beautiful, what matters in the evaluation of experiments, and how ultimately unpack a little bit how the aesthetic responses enter in how we construct an experiment, how we evaluate whether it's successful, and how we receive it. We saw that the reception of the Mesos star experiment is so instructive because so many scientists keep reflecting on its beauty, and it's really interesting that that is such an important part of the reception of the experiment, kind of claiming that it's so beautiful. And I argued that it's quite clear that experiments provoke aesthetic responses. We can look at experimental practice in the early days of the Royal Society when experiments were this public spectacles that were very much like artistic performances, or we can think of modern day experiments. They don't look quite like each other, but we still find that they're received with aesthetic praise. The community discusses them and kind of points at the aesthetic value that they have. So since that is the case, it seems to me important to accommodate, to give an answer to this question. One could say, well, who cares how scientists talk about the experiments? Beauty is just, not worthwhile thinking about. I think it's really important to understand why scientists appraise experiments as beautiful, not as just successful, but as beautiful. So I propose that what these beauty judgments pertain to ultimately is an interplay between design and significance. These experiments that are well designed, elegant, pleasing in their kind of in their design and the way that they are constructed. Ultimately, it has nothing to do with the visual features. They are an extra bonus, but it's not really where the aesthetic value lies in. It's about how the experimenters designed, what the experiment taught us, how significant the results are, and this kind of original thinking that is exhibited in creating the design. And I also wanted to kind of anticipate that I don't want to restrict significance to only experiments that are crucial. I think experiments that have no results sometimes can be even more significant. Experiments that allude to not obtaining results that I expected can be even more significant. So I think this needs to be part of our assessment. And also to, of course, acknowledge that experiments don't just have one goal, they have many goals, and that also needs to come into consideration when we ultimately construct an answers to what makes an experiment beautiful. Now, with all this said, and with 2 more minutes left, I just want to say, this is a paper that I wrote last year, end of last year, early this year. And since then, I've been thinking more about the implications from this. And a couple of things have come to my mind that I really am interested in, that I'm working on at the moment. And perhaps you're already thinking about those kind of next questions and how this project is supposed to unfold. One of the things, as I said in the beginning, a lot of scientists think that aesthetic sensibility is incredibly important, constitutive way of thinking about the world. And you can't be a good scientist if you don't have good aesthetic judgment. We saw that in Chandrasekhar's book. We saw it in Poincaré's beautiful quote here, which I love. This is a special aesthetic sensibility, he says, that plays part as a delicate sieve. And a man who has it not will never be a real discoverer. What he was talking about here is how you get to be creative, how you get to come up with new ideas, and how do you decide what ideas to ultimately pursue. And he argues that it's the aesthetic sensibility that we use, the scientists use, to ultimately sieve through all the different ideas that they come up with. And surprise, surprise, it's those ideas that are most beautiful that we find that end up being more useful as well. But that's like the second step of appreciating the actual utility. First comes in the aesthetic sensibility. And so if you don't have that, you're not going to be a good discoverer, he argues. Pierre Duhem had this really fascinating and problematic notion of good sense, and that's a very, very similar kind of notion to how David Hume talked about, the judges of art. They're the ones that have the good sense, the well-trained aesthetic sensibility, and a lot of insight from these particular scientists and philosophers is about the fact that the discoverer has this feature to them, they're able to decipher and discern the good ideas from the bad ideas, from the useless ideas, based on the aesthetic value that they have. And this aesthetic sensibility is such an important component of a scientist, a creative scientist. Now the question is, well, a lot of contemporary scientists, scientific experiments, are run, at least partly, by machines. And we have assisted proofs and assisted discoveries, but we also have now robot scientists that are not only assisting in a particular step of an experimental design, but also just actually design themselves. And so one of the questions that I'm interested in is, what does that actually mean for, what does it imply for the future of discovery? Is the future looking quite grim in terms of aesthetic value? Are our future experiments going to be completely ugly and displeasing? Or will we have to think differently about the goals of experiments? Will we discover that ultimately these aesthetic features are completely irrelevant, and all we care about is that we get the goods, the results, and the machines are going to do a better job than us in delivering answers? Or are we going to find out that actually, to satisfy our goals, we actually have to implement these aesthetic values, so we won't be looking very happy to just get the delivered results? And another thing, that's a second question that I'm working on at the moment, is what do we do about bad experiments? Not every experiment looks like a nice physics experiment where we're just working with particles or phenomena, we're not thinking about anything bad. But when we think about experiments in psychology and medicine, and we think about how these historically were performed, we find that they're really morally reprehensible. So then, will what I have said so far, how what I have said so far will apply to those kind of experiments? Would it mean that aesthetic judgments and moral judgments will have to be treated completely independently, or will it imply that a lot of these experiments that satisfy elegance and beauty and design and significance cannot actually be given the label of being beautiful? So with that, I will end like open-ended. Here are just some works that I mentioned of mine, but I also have the draft of this paper if you're interested to actually read the fuller, more articulate version of the paper. Thank you so much for your attention.
Thanks so much, Milena, for a great talk. So we'll have a couple of minutes break and then return to the Q&A. Excellent.
Thank you so much.
Those of you who are online, if you would like to ask a question, please put your hand up. And those of you who are here, please bring. Pardon? How long is it? 2 or 3 minutes. Hey, Tony.
Hey. When you asked me about teaching for next, I was also very reluctant to say yes, but I still would appreciate if you asked me closer to the point.
No worries.
I may change my mind.
Yep.
I still haven't really made up my mind. And
that's fine.
If there's any philosophy of science tutorials, I'm always keen.
So that's the one you're most keen for.
Yeah, yeah, definitely. Right. Philosophical logic, I have to decide when the right. Yeah.
All right. I'll bear you in mind in a minute.
Fantastic. Yeah, sure. I mean, I'm sure you also have other people who want to teach as well. Right? So,
but it's good to have a lot of people.
Yeah, exactly. So, yes. Great.
everything went out. Well, I guess you don't know yet. But have you heard anything more about the confirmation?
Well, I recently
Okay, great.
everything. Yeah.
Good,
So
good. Okay, so I think it's to be done.
yeah, that's all good. I guess that's all good now. Yeah. Great. Yes. I must go, unfortunately. But yeah, thanks again also for taking so much time.
Oh, that's fine. It's great. It's fun.
Right. Well, see you.
See you soon.
Bye.